to whoever, and we'll throw you the ball. We find that that's a more convenient way for people to know that they're actually being listened to and get recorded. These talks are recorded for posterity, and you can just Google CMUSV and TOCS, Talks on Computing Systems, to get them. We've had a tremendous number of talks, well over 100, from most of the luminaries of our community and our industry. Today we have a speaker from Microsoft, actually, and he's such an itinerant hacker that he's going to talk about hacking itself. He's going to talk about the tools that he uses and methodology, modern methodologies for debugging and creating code, if I understand it. It's Mario, and your last name?
Hewardt.
Hewardt. So, and he's from somewhere in Europe at some time distant past, but he spent 15 years at Microsoft, and maybe at lunch we convinced him to come get a degree from here too. But in any case, thank you for coming, and we will at 2:30 then go off into the hallway where we'll have a little bit of cookies and soda where people can get a little bit better to know you. Okay, thank you very much.
Hey guys.
Hello.
How are y'all doing?
Good.
Good. Is the sound coming?
Yeah, it's great.
It's fine, okay. So this is the talk on Intro to Advanced .NET Debugging. It's kind of a strange title. It's an introduction to something advanced. But the tools that I'm going to be showing today are sitting at a very, very low level, close to the operating system. So if you're used to development environments like Visual Studio or Eclipse, you're going to be a little shocked when you first see these, but they are extremely powerful tools that allow you to peek inside the internals of the operating system and your applications. I'm going to spend a few minutes talking about the importance of debugging. Why should I even care about being an effective debugger? As software developers, we write perfect code. We don't ever have bugs, right? So why should I even care about this stuff? Common traits is a question that I get is, well, what traits do you see in people, and as far as being a great debugger? So we'll talk a little bit about that. Then we'll jump in and talk about available tools, do some basic tasks and walkthroughs, things that you will do pretty much on every single debug session that you encounter. And then we'll spend a little bit of time talking about this all-important notion of postmortem debugging. And the sort of overview of postmortem debugging is when you have an application that you've written, it's gone onto a customer's machine or it's been deployed to the data center, right? In those cases, you need to have the right tools to even be able to debug anything out in the wild. And we use postmortem debugging for that quite a bit. What I'm going to be talking about today are the internals of the CLR. That's the runtime of .NET. And as such, anything that you'll pick up from here is applicable to any other sort of higher level frameworks like WCF or ASP.NET, because they all sit on top of the CLR. And we're going to skip the pop quiz today, because I'm nice. A little bit about myself. I'm a developer, premier field engineer at Microsoft. Basically what that means is that I go out to my customers and they have me do anything development related that they want, really. If they want me to design or architect a new front end for their websites, I go and do that. If all their sites are going down and they're losing a ton of money, then I come in and help them troubleshoot problems and get them back up and running. I've been at Microsoft for close to 15 years now, and I've been at the OS level for most of it. So I think the first bits that I dropped was into Windows 98. And as part of those 15 years being that close to the OS, my passion has been around software reliability. And that gave me the opportunity to use these tools called debuggers to gain insight into how the system actually works. I also set out on this ridiculous quest to educate the world on the importance of reliable software. So I've written a couple of books on it. One is Advanced Windows Debugging that covers the internals of Windows from a native point of view, so C, C++ type of a thing. And then I did a follow-up that's focused on .NET and the CLR itself and the internals. And writing a book is kind of an insane task. That's the best way to describe it. It's kind of like a software project, really. You start out with all these things that you want to put in there, and then reality hits. And you have to kind of start chopping things off. And the things that I ended up chopping off, I write for Dr. Dobson and for MIT, and they're free articles. If you're interested, you can go out and read those. Okay, so the importance of debugging. I'm going to try to motivate you in as far as debugging is concerned by showing some stats. So the first one was a study done by a CTO of a company. And the question was, how much do software defects cost you? If you're sitting on your machine as a developer in your office working on your little piece of the puzzle, the cost of fixing it is cheap. It's $1. When you take your piece of the puzzle and actually insert it into the bigger picture, the cost goes up. And it goes up to, he said, $100. Once the actual solution is deployed, whether it's running in the data center or on a customer machine, if you have a bug, it's in the thousands. As a matter of fact, there's a stat out there that says that anytime Microsoft releases a hotfix, for example, for a security issue of some sort, it's upwards to $100,000 to get that fixed and out on customer machines.
Wow.
So it's a tremendous amount of money. The second study, a typical software development project, 80% of software development dollars are spent on defective software. So really that means 20% of the cost is just getting the thing out the door, and the great majority is actually maintaining that piece of software, making sure that it works for the customers. Lastly, and I'm going to throw this question out there, how much money do you think software defects costs the US economy on an annual basis? Anyone want to guess?
Several billion.
Several billion? Yeah. So it's $60 billion. The study was done in 2002 by the United States Department of Commerce, National Institute of Standards and Technology. Just a fairly substantial amount of money that's being lost due to this. There are things, obviously, we're not going to drive that down to zero, but there are things that you can do when the problem surfaces. If you can effectively and quickly troubleshoot the problem and get to the root cause, obviously that's going to decrease your losses and this number significantly. Here are kind of 3 bullet points that also ties into the importance of debugging. Perfect code is an illusion. I'm sure, as software engineers, we don't like to hear that because we're all perfect software engineers. We don't write any bugs, right? And that may very well be true. I mean, I'm pretty sure everyone in this room is an excellent software developer. However, we get put into conditions or scenarios sometimes that doesn't necessarily enable us to do our best work. So your boss comes in and says, our competition, they're shipping earlier than we thought. Let's pull the schedule in. And then all of a sudden, you're working 18 hours a day for 3 weeks. It's not really the greatest environment to be writing perfect code, right? And we have to deal with those things. Another reason is legacy code. I don't think I've ever met any software engineer that goes to a company and basically gets told, I want to write new code all the time, and that's all they get to do. Chances are they've got a V2 up, or V1, V2, V3. Customers are actually actively using that. That code may have been written 10 years ago for hardware that maybe doesn't even exist today, but they are still running it. Customers are very reluctant to continuously upgrade. So you're going to have to be able to deal with legacy code that you haven't written, and being able to troubleshoot it. Lastly, deeper understanding. If you really get your head wrapped around the debugging mindset, it is going to open up kind of a new world, because you start looking into the internals of the system, whether that be Windows or Unix or .NET, whatever the case may be. And that is really going to help you write better software moving forward. Like, I have rarely seen an engineer that spent 24 hours a day for a week straight debugging one issue. That person is not going to make that same mistake moving forward. Some of the common traits for good debuggers is willingness to venture outside your own code. Very often we write our code, and those are the boundaries that we're comfortable with. Right? If something bad happens in your application, we look at our code only. we need to expand that view a little bit and say, anything that I'm dependent on, I also have to have a relatively good understanding of if I'm going to have a chance at troubleshooting certain things. And here's an example. You've got, in the old world of, for example, C and C++, where we don't have garbage collection, we're still required to actually free our memory, right? If in your application you did something wrong and you corrupted memory, or you corrupted the integrity of the memory itself, the crash that's going to happen will show up in the heap manager itself. Not in your code if you look at the actual call stack, but in the heap manager. And a very common thing there is to say, well, it's a bug in the heap manager. I'm not discounting the fact that there could be bugs in there, but in the case of the heap manager in Windows, you've got these guys that have been sitting in the rooms for 30 years writing this stuff, and again, there might be a bug in there, but you really need to do due diligence to be able to actually come in and say, I have exact pinpointed thing proof that there is a bug in the heap manager. Otherwise, your code might be the result. Patience is another one. The best way I like to describe the act of debugging is kind of like a big tree, in a sense, where you get presented with a problem. The root node of that tree is the problem. You start creating some theories around what could have led up to that. And those theories become kind of subnodes of that tree. You drop down to each of those nodes, create new theories, and you end up with this one big tree, essentially. And your job is to find the right path down this tree that gets you to a root cause. And usually there's only one. And a lot of times you're going to end up going down the tree all the way down. You're going to realize that it was dead end. You back up and you go down the other path again, right? So you're going to have patience when you first start out. Having said that, as you do more and more debugging, you're going to get better at it. You're going to be able to spot patterns, which allows you to pretty much prune that tree right out of the gate, and your task has become a lot smaller. By the way, Ted, do we take questions, or do we do that?
Anytime.
Anytime? Okay, yeah. Feel free to jump in anytime you want if you have any questions at all.
Just
Pass the
raise
ball.
your hand and I'll send you a ball. We'll talk from here.
Any questions so far? Nope. All right.
We'll bark up the different tree.
So tools of the trade. As far as debugging on Windows, I see a lot of Macs. So there's one PC. So the tool that usually comes to mind is Visual Studio, and I think that's pretty much the same as Eclipse in the sense that it's this integrated development environment. It's got a fancy debugger, set breakpoints, bring up call stacks, all these pretty things, right? Yet another option, which goes slightly lower, is Core DBG or MDBG. This is a console-based debugger, so it's not going to have the fanciness of Visual Studio. It's a lot smaller, and it allows you to do managed code debugging. The last set of tools, and those are the ones we're going to focus in on today, are debugging tools for Windows. Those are probably the lowest level debuggers that you can conjure up. They're not as nice as Visual Studio, but they're incredibly powerful. Not just from the point of view of debugging your applications, but just getting insight into whatever abstraction you're working on inside of Windows, inside of the CLR. So that becomes really useful. So what is it about debugging tools for Windows that sets it apart from Visual Studio, for example? Number one, it's got a small footprint. And this is actually a pretty important one. When you install Visual Studio, I don't know about Eclipse, but when you install Visual Studio, standard install, which brings down a lot of stuff, you're looking at maybe 1.5 gig of just file system space, right? And that's not even counting all the configuration changes it does on the machine. It might install some new frameworks, puts various pieces of software in there. So the niceness of Visual Studio comes with that cost. If I've got my software and I've deployed it to the data center, right, I don't have any access to the data center. I basically tell the operations engineers, here, go and deploy this thing that I wrote. If something bad happens and I need to debug it, I can go to the ops engineers and say, hey, I want to install Visual Studio, and they'll either laugh at you for a really long time or just hurl an insane amount of profanities your way, because their job is to keep those machines in pristine shape. They don't want anything installed on them. And they definitely don't want anything that will change the configuration of those machines because they're the ones who are responsible for them. So an example of this might be Visual Studio installs .NET 4.0, but your application only depends on 3.0. Well, now all of a sudden, the ops engineers have to support .NET 4 on that machine, even though it's not even being used. Right? And they frown upon that. So Debugging Tools for Windows, the package, it's got a very, very small footprint. I think the install package itself is only about 16 megs, so it's tiny. And it doesn't do any configuration changes. As a matter of fact, you take the debugger, one executable, put on a thumb drive, plug it into the machine in the data center, you can run it off the thumb drive. That makes the ops engineers very, very happy. So it's ideal for debugging problems on machines that I call lockdown. Data center is one example. The other great thing about it is because they're at such a low level, in the sense that they're right on the operating system, whenever we rev the OS, like going from Vista to 7 to 8, these debuggers get updated as well, so that they understand the new features of the operating system coming up. So they get revved quite a bit. And as far as what actual debuggers is present in that package, there are two categories. One is the kernel mode debugger. We're not going to talk about that today at all. This is mostly for device driver developers. And then we got the user mode debuggers. The user mode debuggers, there's three of them. Windbg, NTSD, and CDB. Right? The only difference between them is the presentation layer, if you will, the UI. Windbg actually puts a UI on top of these debuggers. It tries to kind of mimic Visual Studio. So it has windows for threads, it has windows for local variables, and things like that. You have to keep in mind that the people that are writing these debuggers are low-level OS people at Microsoft. They don't do UI, so don't expect the Visual Studio experience when you're using Windbg. The other two are console-based, NTSD and CDB. The key thing about these three debuggers is that they all work on the same debug engine. So anything, go ahead.
Why are there three and they're separate?
Why are there three and they're separate? So that's a good question. Windbg, let's start from the other direction. NTSD and CDB, console-based completely. Brings up this window and a bunch of text. No menus, nothing like that. My feeling or my guess would be that people still wanted the power, what the debuggers offered, but they also wanted some sort of a UI. So they created Windbg because it has a UI attached to it.
Is it the same? Is it the same code base? Is it a layer on top of it, or
yes, it's the same code base.
Okay.
So the core debug engine itself, the same across all three. Whatever you can do in one, you can do in the other. It's just the fact that there's a different UI. That's all it is. Lastly, it's got powerful extension models. So it's got things. If you want to debug DCOM, it has an extension in there that allows you to get all the detail you could possibly want about DCOM, RPC, security, things like that. If it doesn't have something that you need or something that's very specific to your app and you wanted to create your own extension, you can do that as well. It's just implementing a set of APIs, compiling it into DLL, and voila, you got your own extension. Any other questions? No. Great news about these debuggers, they're actually completely free of charge. So if you want to install them, you're going to have to go to Microsoft.com and install the Windows SDK. There's a web installer for it. And when that installer runs, the first thing it brings up is a dialog that allows you to choose the things that you want to install. You can deselect absolutely everything and just install the Debugging Tools for Windows package. So that gets you around having to install another gig worth of stuff that the Windows SDK comes with. Install is pretty trivial. Just click your way through. By default, it goes into Programming Files, Debugging Tools for Windows. That's the location of it. And that's just an example of the three debuggers the three user mode debuggers that we just talked about. You can tell that they're actually pretty small. I mean, Windbg, which is the one that has the UI, is 0.5 meg. You can literally take that thing and put it on the thumb drive, like I mentioned, and just run it off the drive itself. Okay, so let's look at some of the basic tasks. We know what they are. We've got them installed. And what do you do with a debugger? Well, essentially, there are two things that you can do. You can start a new process under the debugger, right? So as soon as the process comes up, the debugger is attached and you're running. That's great if you want to kind of debug maybe some startup stuff that's happening in your app. A lot of the times, though, you will have an app that's running for a week and periodically, something bad happens. In that case, you don't necessarily want to run with the debugger attached from the get-go. Rather, you want to attach the debugger to an already running instance. If you wanted to attach to running instance, you can use the -p switch and you specify the process ID. So every single process in Windows is uniquely identified by a PID or a process ID. That's the one you would specify. You can find it through a large number of ways. The easiest is just Control-Shift-Escape. That brings up the task manager, and in here you'll have all the processes running, including the process IDs. If you're lazy like me and I don't want to go find the process ID, you can use the process name, and then you use the -pn switch followed by the name of the process. Of course, if you have multiple instances of process running, say you have 3 instances of Word, the debugger is just going to complain and say, you got to revert back to the PID because I don't know which one of them that you're actually interested in. If you're starting a new instance of a process under the debugger, it's pretty trivial. You just specify the command line. By the way, in all of my examples, because I'm not a UI kind of guy, I'm a console kind of guy, I use NTSD, but you can switch that out to Windbg or CDB, whichever one of the 3 that you like. One caveat here is when you start a process under the debugger from the get-go, Windows is going to make an assumption for you, a fairly reasonable one, is that you're probably looking at debugging some issue. And it's going to try to help you. So it will actually put certain components of Windows into extended instrumentation mode. An example of this is the heap manager. For example, if you're allocating memory in your app and you're running this instance under the debugger, the heap manager is going to pad the allocations with special patterns so that if you're doing something bad where you're corrupting the heap, you can catch that a lot quicker. So you might see a slight difference in experience from running under the debugger versus attaching because of that extended instrumentation. Any questions? Let's do a quick walkthrough. You can kind of see what this looks like. So I wrote a very, very, very complicated app here. It's called o3simple.exe. And what it does is this. Super complicated. It took me a week to write. Just dump some stuff on the screen, okay? Now, if I wanted to start a new instance of this process under the debugger, I would use NTSD, o3simple, and you end up with this, which looks quite different from Visual Studio or presumably Eclipse. A lot of numbers, a lot of low-level stuff. But what it essentially does, it tells you all the modules that have been loaded. So in this case, since we're starting the new instance of the process under the debugger is going to break at the earliest possible moment that it can. And that's after it's mapped in some of the OS level binaries into your address space. So kernel 32, kernel base, things like that. And then really you see this blinking cursor down here, and all that the debugger is doing right now is just asking you to enter some commands for your debug session to figure out what is going on. The process is suspended at this point. So if this was a service that was processing requests, those requests are going to be denied. Right, this is live debugging. Now if I start the same app in the background, and I want to attach to it, I could do ntsd -pn because I don't want to look up the PID, and do o3 simple.exe, the name of it. And there it comes up again. Now you're actually attached to that running instance. Now you'll notice that there's a lot more modules loaded in, which makes sense because the process is already initialized and it's been running for a bit. So that's the experience of how you would attach or run with the debuggers. Are there any questions? Toss it, toss it. I want to see toss it.
So I mean, I understand that your job is a lot of times, especially for you, you go into places and you have to find the problems and stuff like that. But you know, a lot of us are developing code, and what would you recommend that we do to prevent having to call you to fix it? Like, well, that's when we're coding it and building it.
Right. So that there are obviously a lot of different things that you can do in as far as making sure your software development processes are up to whatever standard that you're looking for, right? And that involves, there's a lot of different methodologies. There's test-driven development. There's actually a methodology around debug-driven development, where when you write a new piece of code, and the only way for that to be considered pristine is if you ran through every single scenario, every single line of code you step through in the debugger, right? So you can also utilize a lot of automatic tools that are out there today. There's things like, one is called prefix or prefast. What that does is procs your code statically and looks for common patterns of issues like memory buffer overruns and things like that. So I think a combination of the right methodologies and the automated tools that exist to catch these things is kind of key.
Do you see, like, since you basically fix all the problems of debugging, do you like see like common mistakes that people mistake?
Oh yeah, all the time. There's patterns to a lot of these problems. It's very, I'm not going to say it's infrequent, but I see the same patterns repeating themselves over and over again. And I think that's also as a result of not necessarily understanding the internals. So I'll give you an example. In .NET, we have this beautiful thing called the garbage collector, right? It's a new world. We don't have to free our memory anymore. It's awesome. Yeah. Given that, I end up spending more than 50% of my time in managed code debugging memory issues. Right? And that's just because people don't necessarily understand how the garbage collector works. Very common example, you define a static in your class, and it references a media player that you've loaded up a 300 meg media file in. From the developer's point of view, they're kind of like, well, I've used this now, but I'm not using it anymore, so why isn't the garbage collector freeing it up? Well, because the static is going to be there throughout the duration of the app, and is always going to be considered a live object. Garbage collector can't do anything if it's live. So there's a lot of patterns like that I see. I think part of the solution for that is just educating software engineers on how things kind of work. Does that answer your question?
Yeah.
Okay, so the next thing that always pops up in any debug session, they're called symbols. And basically what symbols are is just auxiliary metadata about your code, basically. In the native world, so non.NET, say you wrote an app in C++, if you'll put that process in the debugger, it would tell you something bad happened at the following location, and the location would be 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't really know what that means. I have 300 functions in my app, and I don't know what that maps to. And the solution to that is by using symbol files. That's just a separate file, PDB file in the case of Windows. I'm sure there's something similar in the Unix world. And if you point the debuggers to those symbol files, it will know how to get the textual representation, the symbolic name of whatever is happening in the process. So instead of getting something bad happen at 1, 2, 3, 4, 5, 6, 7, 8, you get something bad happen in Mario Funk. And that's obviously a huge, huge thing when you're doing debugging to more efficiently be able to get to where the problem is. So symbols are good. In the native world, without them, you are going to be in for a lot of pain if you do debugging. In the managed world, though, they're not that important anymore. And the reason for that is because .NET is far more self-descriptive. A lot of the things that end up in the symbol files in native world is now in the binary itself in the managed world. So you don't no longer need that separate file. As a matter of fact, probably 99.5% of the time, I never use symbols when I debug managed code. Just because the data that's there to begin with is just sufficient. If you want to tell the debugger to use a particular set of symbols, you got to use some of these commands. One is .simfix. What that command does, it tells the debugger, go out to the Microsoft public symbol server, because we keep one of those around, and it will pull down symbols automatically for you, the public ones. So that you don't have to worry about which version of Word am I using, is it a hotfix on top of it, where should I go and find those symbols. It's just streamed down automatically. If you want to append your own symbol path, because chances are you're debugging your own app, you want to use the .sympath plus command, followed by whatever path where your symbols reside. And lastly, because all you've done so far is told the debugger, here's where the paths are, you got to tell it to load the symbols from those paths and use the .reload command to do that. So let me show you what that looks like. I'll use the same app here. We use the same app, o3simple.exe, and as soon as it loads, I want to find out what is the current symbol path in our debugger. Of course, it says none, because we haven't said anything.
Thank you, Dennis.
And I'll do a .simfix to set it to the Microsoft public symbol servers. By the way, these debuggers are kind of Unix-like in the sense that if you run a command and it tells you nothing, it means that it succeeded. You're going to get, most of the time when you get output is when some errors happen. Now we can use .sympath, and you'll notice that it's updated it to this URL, and that's where the public symbols are for Microsoft. And then I can add my own path by doing .sympath plus. And finally, a .reload, which will reload the symbols for all the modules that are currently loaded in the process. Any questions on the symbols?
Is your debugger stack frame aware that it can tell on a particular stack frame what the names of the variables by symbolically?
It can, yes, absolutely. So let me actually just show you that. I'm currently sitting on thread 0 in this app. And if I do the command called kb to get the call stack for that thread, scroll to the left here. You'll notice the function names themselves, and then you can go to a particular frame of that call stack, say frame 1, and if I do a db, it will tell me the local variables. In this case, that frame is a Microsoft frame, and since we only ship the public symbols, you won't be able to get the local variables, but had this been your own code, it will show them. So that's one of the things also I wanted to mention is that there are two types of symbols. There's the private symbols and there's the public symbols. Right? The private symbols contains a lot of information to make your debug session really easy. The public symbols are stripped down from that. Anyone want to venture a guess why we have two different, public and private?
Maybe like code gets messed up. Like that's the reason why you have private variables, so certain things can't see certain things.
Okay, so we've got the, in the case of private symbols, right? If I wanted to try to reverse engineer some top secret thing that Microsoft has spent 10 years researching. With private symbols, if we ship them, we just made my life a lot easier because I can see a lot more, right? So all of a sudden, my reverse engineering, the complexity of it becomes a lot smaller. Similarly, for if you're working, for example, at a company that releases a framework for your customers, you don't want to give them the private symbols for that because you might have some IP that you're protecting in there and you don't want it to be that easy. That's pretty much what it boils down to. Okay, so now let's kind of move in on the managed code side of things. The debuggers themselves, like I mentioned, they're like down at the OS level. They don't understand anything about managed code. All they know is that there's just some process running some machine code, right? So if we wanted to use these debuggers to do managed code, we're going to need a little bit of help. And we're going to use an extension that's provided called SOS, stands for Son of Strike. And that thing allows you to look at the managed code aspects of the process. So things like, tell me everything that's in memory right now. Or tell me what the managed code call stack is. Tell me what the finalization queue looks like, things like that. We always got to use SOS when we do managed code. To load it, up until .NET 2.0, you would use .loadby space SOS space MS-core workstation.dll. And in 4.0 and beyond, you would use .loadby space SOS space CLR. And what this command does is basically says, I want you to load the SOS extension from the same path that MS-core WKS is loaded in. That way you don't have to go off and type this really, really long path to the SOS extension, and it's just really a neat shortcut, because SOS and MS-core workstation.dll will always sit side by side, always. The help system for SOS is actually phenomenal. Traditionally, the helps for the debugging tools for Windows, the debuggers, and most of the extensions is really pretty pathetic. Like you type bang help and it tells you what the name of the command is, but nothing else. SOS actually has a phenomenal help system. You can get help, from the overall point of view of the extension, you can get help on specific commands. And if you do that, it's even going to give you examples out of debug sessions on how that command was used. And you would use bang help to look at that. A couple of other extensions out there, SOS-EX. It's not a Microsoft extension. It was written by a gentleman named Steve Johnson. And great extension. It automates a lot of things that you end up doing in the debugger quite frequently. But as I mentioned, it's not Microsoft. He kind of does this. Microsoft saw this extension and promptly hired the guy, but he's still doing just things on this extension on his own time. So it's not supported by Microsoft at all. But he keeps up with it pretty well. One other extension is PSS Core 2/4, depending on if you're using .NET 2.0 or 4.0. And that is an extension that is Microsoft. It came out of the support organization, and it adds commands around IIS debugging. It's really a superset of SOS, so anything you have in SOS, you also have in PSS Core, but it adds a few commands around web debugging, per se. All right, so a quick walk through here on how to load it. Use the same app again, and let it run for a bit. And then I do it on load by, actually I need to fix up my symbols. And that's it. This is the .NET 2.0 app, so I used MS-core WKS.dll. If I type on, do the help command, you can tell that it tells you what all the different commands are, and it kind of categorizes them into buckets as well. Let me just run one of these things. What if you wrote an app? Let's say it's using C or C++, right? It's not managed code. And that application, for some reason, just consumed enormous amounts of memory. Right, what would be the next kind of question that you would ask yourself if you wanted to figure out why it's using all this memory?
Maybe like algorithm efficiency?
Algorithm efficiency, okay. So you could go back to the source code and you can kind of look at algorithmically how it works, right? And where memory is being allocated and things like that. What if the app was just enormous? Where going back and looking at all the different algorithms and the source code is just not feasible, really. What would be sort of the second question that you might ask yourself if you see a process consuming, I don't know, 10 gigs of memory?
Memory leak.
Memory leak, okay. And to get to the bottom of that, we would kind of want to know, well, what's in memory?
Heat.
Sorry?
Heat.
Heat, okay. So we want to find out, you know, somehow tell the heap manager to dump out everything that's in memory, right? With native code, C, C++, that is a very hard thing to do because it's just a bunch of numbers. There is no context to what's in memory. If I allocate a block, if I allocate a string in C, right? The heap doesn't know that it's a string. It's just a block of bytes. So by dumping all the memory, all you're going to see is just a bunch of numbers, but you don't really know any context behind it. So it becomes a little tricky. And in native code, you would use some other tools. But in the native side, in the managed code side of things, because it is far more self-descriptive, the managed heap itself, the CLR heap, has that auxiliary metadata attached to the heap. So if I did dump heap, which is an SOS command, and -stat, and just pretend that this is an app that's using 10 gigs of memory right now. If I ran that, it gives you a statistical breakdown of everything that is on the managed heap. Tells you the number of instances on a per class basis and the total size that it occupies across all those instances. The other great thing about the dump heap command is that it sorts this by total size. So at the bottom, you're going to see the biggest hitters. So if this truly was a case where 9 gigs or 10 gigs was used up by strings, I would just go to the bottom of this output, and they would say system.string, total size of 10 gigs across, I don't know, maybe 1 million instances or something like that. So this form, or the self-descriptive nature of the CLR is really powerful, and it really helps you far more when you're debugging managed code versus native code. And once I have this type of information, well, now I can say, let's see, dump heap -string, I think it is, strings. Now it tells me all of the strings in that process and what they actually contain. Chances are if there was 10 gig worth of strings, there's going to be a pattern in here, and from the context of what's in those strings, I can now go back to source code, more pinpointed part of the source code, and say, hey, how did I leak these strings? Any questions? Yeah.
This, it's kind of harkens back to the early days. It's got this feeling, this, the colors on the screen are reminiscent and all that, the font quality. And I guess the real thing that I know that you want to share with us is what are the insights coming back to this from the super fancy tools that we're used to these days, and how do you manage the relationship between when you use those and when you use these, and yeah, what's the news that really we wouldn't have thought of when we were playing with this style decades ago.
So I'm kind of showing these debuggers, and they kind of look the way they do. Like you said, it brings you back to 20 years ago, whatever. This isn't, by no means, you shouldn't use these guys exclusively. Like Visual Studio or Eclipse, when you're sitting in your office or whatever and you're coding, use those tools. They're beautiful, right? They're very easy to use. You have shortcuts for everything, and it's got the sexy UI. It's just really easy to work with. These tools are great when something bad happens out in the wild, right? Where I can't toss Visual Studio to the customer and say, you know what, I hate the UI of these other debuggers, so please install 1.5 gigs on your machine. Right? It's just not workable. And in those cases, you do have to make this transition over to more lightweight debuggers like this. And the transition itself is obviously substantial because these guys are kind of low level and hard to digest, but once you come to appreciate the power of these, that sort of learning curve goes down by quite a bit.
If the heap dump identifies a gigabyte that I think should have been free, will it explain to me why it thinks it is not free? Where is the reference to this thing?
So that's a good question, and we're going to get to that in a slide or two. That's a very good question. That is the next natural question, right? Is
The fact is, though, that 2:30-ish, we want to
how much time do we got left?
yeah, just a couple minutes here.
Well, let's speed things up.
There's one more question.
Sorry.
Hello, Mario. My question is that it looks like you prefer to use SOS, and in your book you also use SOS, but Microsoft internally they usually use they more prefer to PSS core. So when you are actually debugging in the customer sites, which tool do you use?
I use SOS. Most of the commands that I end up using, because PSS core is a superset, most of the commands that I'm using are in SOS, right?
Yes.
There's one thing about this though, is SOS, whenever we rev the CLR, you will always get the latest version of SOS, always. PSS core 2 and also SOS EX will lag behind a bit. So I always find it useful to know how to do things in SOS that are otherwise automated in PSS core, just so I can always fall back on that, if that makes sense.
Okay, that makes sense.
All right, well, for the sake of time, there are a couple of commands around threads. I'm not going to talk about what threads are, obviously, because we all know that. Bang threads will give you an abbreviated list of all managed code threads running in that process. Bang CLR stack gives you the managed code call stack. And then the highly intuitive command, ~e bang CLR stack, will dump out every single managed code call stack of every thread in the system. Very useful when you're looking at processes that have 1,000 threads, which I've seen. And I'm sure Alex has seen as well. Garbage collection in the CLR, 3 generations, Gen 0, Gen 1, Gen 2. Basically all it does, it checks to make sure that every single object on the heap has a reference. If it doesn't have a reference, it will clean up that memory for you. Ties back to the question coming over here is, how do I find out who holds references to this, right? We've identified 10 gigs of strings. For that, you can use bang gc root. Basically what that command does, it does exactly what the gc will do when it determines if something is alive or dead. And it will show you the reference chain all the way to that string. Postmortem debugging. I do want to touch on this a little bit. Do we still have a few more minutes? Or is it tight? So when live debug scenarios are not feasible, like in the data center or in the customer machines, you just can't do live debugging, right? Even if they allowed you to do it, the process will be suspended when you debug, meaning no request will be serviced, you're going to lose a lot of money. What we have to do in that case is what's known as postmortem debugging, and all that is a static snapshot of the entire process memory space. It dumps it out to a file. You take that file, you move it off of the customer machine or in the data center, and you put it on your dev machine. Use the same debuggers to debug this dumped file instead of doing a live debug. Clearly, there are some limitations. You can't set breakpoints. You can't resume execution because it's just a memory dump. But you can introspect on the state of the CLR and your app, and from there figure out how you got into that problem. The switch that you want to use for the debugger is -z, and then just ntsd -z, and then the path to the dump file itself. So that was a very quick overview of postmortem debugging. But it's highly, we use this all the time. We don't have access, like when I go to my customer, and it's a bank, their stuff is running in the data centers, this is all we use, because we cannot get physical access to the machines. All right, we're skipping the pop quiz. I'm not going to be mean today. And that's it. Thank you very much.
So at this stage, we typically have some questions. I just am worried about some people probably have other meetings to go to. So why don't we take the questions out into the hall? Really appreciate you coming, and I'm sure there's some people that have actually even read your books that are going to ask you some questions here. Yeah. Dennis, you got the recording?
Good, how are you? Great. Yeah.